Alright, so in this KSP problem we're looking at two solutions, sodium sulfate and an aqueous solution, also barium nitrate. And when we mix two of them together, we want to know whether a precipitate will form or not. So in order to figure this out, the first thing we have to do is figure out what what KSP we're looking for here, what our solid might be. So I'm just going to do a net ionic reaction. So I'm going to first sort of break this up into its constituent parts. So we have 2Na plus, and we have SO4 2 minus, and we have Ba2 plus, and 2NO3 minus, right? Because of the sodium in the first instance and the nitrate in the other, this is completely soluble. So I'm going to try them sort of the other way, and we'll take the sodium and put it with the nitrate, so we get 2NaNO3, which is aqueous, so realistically those exist as 2Na plus and 2NO3 minuses, so those are just spectators now. And the other one is plus BaSO4, barium sulfate. That will be a solid, and now when we take a look at this, those are gone, those are gone. So here's our net ionic reaction. It's Ba2 plus SO4 2 minus going to BaSO4 solid. Okay, so we now know what we're looking for. We're looking for a concentration of barium 2 plus, concentration of sulfate, and we want to know whether that reaction, whether there's enough concentration there to make barium sulfate solid. Okay, so I'm going to get rid of this. Okay, so we know that the reaction that we're looking at is barium sulfate. I'm actually going to flip from the net ionic reaction because KSPs are written the other way. Solid, going to barium 2 plus and sulfate, so SO4 2 minus. And what we really need to find right now is the initial concentration of barium and the initial concentration of sulfate, right? If we were to go and make a rice chart. The question is this a minus or a plus x? And same here, is this a minus or a plus x? Right, the only way we can do that is by comparing where we are at the initial, here and here, compared to where we are at equilibrium, and find out, do we need to make more products to get to our K, or do we need to make fewer products and more reactants? Will we make the solid, in other words? So we're going to have a Q and a K problem here that we're going to need to do. First thing we need to do is we need to find the initial concentration of those two, though. So I'm going to use M1V1 equals M2V2, right? So we're going to set this up where the molarity 2 is equal to the molarity 1 times V1 over V2. Okay, and so for the barium 2 plus, we're going to set that up, and it's going to be equal to 3.2 times 10 to the negative fourth molar barium nitrate times 0.1 liters over the total of 0.11 liters. It's V1, V2. Okay, and because there's just one barium for one barium nitrate, it's going to be sort of a 1 over 1 Ba2 plus over 1 BaNO3 2. And so we're going to get out that that comes to 2.9 times 10 to the negative fourth. I'm going to do the exact same thing for the molarity of the sulfate. Okay, the only difference is going to be, instead of 0.1, I'm going to use the 0.01, which is the amount of the sulfate. So we have 0.0020 molar Na2SO4. Okay, it's going to be 0.01 liters over 0.11 liters. And that is going to also be 1 SO4 2 minus over 1 Na2SO4. Okay, that one is going to come to 1.8 times 10 to the negative fourth. So now we can plug this in and we can say, well, our initial concentration of barium up here is 2.9 times 10 to the negative fourth, and the initial concentration of sulfate is 1.8 times 10 to the negative fourth. And now we have what we need to compare the Q and the K. So if we write out, we can remember that the KSP for this case has to be equal to the concentration of Ba2 plus times the concentration of the SO4 2 minus. And so we're going to type in our QSP where we're going to check our initials and see where we are relative to that. So in order to do this, we need to look up the KSP of barium sulfate. It happens to be equal to 1.08 times 10 to the negative 10th. Okay, and now I'm going to set the Q. So Q is equal to 2.9 times 10 to the negative fourth times 1.8 times 10 to the negative fourth. And here we go. Q therefore is equal to 5.2 times 10 to the negative eighth. That makes Q greater than K. If we want to write it, QSP is greater than KSP, which means we have, remember from equilibrium, too many products. Therefore, this reaction is going to have to go back towards reactants, the reactant being barium sulfate solid. So will precipitate form? Yes, it will, because Q is greater than K. So yes, precipitate will form. Okay, and that's what you need to do to prove it. You need to find the Q, you need to compare it to the K. Okay, you can also, from this point, if you wanted to know what the equilibrium concentration of those things are going to be, you now know that it's minus X and minus X here. So you could go ahead and just say, okay, now it's 2.9 times 10 to the negative fourth minus X. And 1.8 times 10 to the negative fourth minus X. You can take those and plug them in and go ahead and set that equal on your calculator, solve for X, and you can figure out therefore what the equilibrium concentrations were, or even how many grams of precipitate were formed using that X.